Welcome. Today we will solve a numerical on V by F control of synchronous machine. So, the problem is like this: a 6 megawatt 3 phase 11 kV star connected 6 pole 50 hertz 0.9 leading power factor synchronous motor has synchronous reactance XS equals to 9 ohm and RS equals to 0 ohm. Rated field current is 50 ampere. Machine is controlled by variable frequency control at constant V by F ratio up to base speed and at constant V, that is the rated voltage above base speed. Determine bit 1 torque and field current for the rated armature current 750 rpm and 0.8 leading power factor. Second bit armature current and power factor for half the rated torque 1500 rpm and rated field current. Third bit armature current and power factor for regenerative braking power output of 4.2 megawatt at 750 rpm and rated field current. Fourth bit torque and field current for regenerative braking at rated armature current 1500 rpm and unity power factor. We will solve the numerical. First thing, at rated condition, voltage V per phase voltage of the stator, that is 11 kV is the line voltage and star connected. So, 11,000 by root 3, that is 6350.85 volt, and synchronous speed Ns is 1000 rpm as it is 6 pole 50 hertz machine, and rated power output is 6 megawatt. So, neglecting the losses, power output equals to power input. Power input is 3 V IS cos phi equals to mechanical power output PM. 3 V is 11,000 by root 3, IS cos phi is 0.9 at rated condition. So, rated power output is 6 megawatt. So, this implies the rated current, rated stator current IS equals to 349.9 ampere. At rated condition, what is the induced EMF, stator induced EMF per phase, that is E, and E phasor is voltage phasor V minus JXS into IS, applied voltage per phase minus stator reactance drop, IS phasor. So, that is phasor EMF. So, per phase voltage is 6350.85 and this is always the rated, always the reference phasor, minus XS is given as 9 ohm. So, reactance is 990 and rated current is 349.9 ampere and angle is cos inverse of 0.9. So, computing this, the rated at rated condition induced EMF comes as 8227 at an angle of minus 20.15 degree. So, these are all rated conditions. So, first bit we will solve. For operation at 750 rpm, the supply frequency must be proportional to the speed. Speed is 750 rpm, synchronous speed is 1000 rpm at 50 hertz. So this is 0.75 times 50 hertz. So frequency is 37.5 hertz. So because of constant V by F ratio, phase voltage, applied phase voltage V1, I have written as V1 because it is different. V1 is frequency is 0.75, V by F ratio is 0.75, so that this is 0.75 times rated voltage V, 0.75 times rated voltage is 6350.85. So this comes as 4763 volt, and the reactance now it is different. So it is XS1, that is 0.75 times 9 ohm is the reactance at rated frequency. So it is 6.75 ohm. So induced EMF per phase, for this condition we will denote it as E1 is voltage, applied voltage V1 minus JXS1 into IS. Current is the rated current, in the first bit it is mentioned stator current is the rated current, and V1 because of constant V by F control, V1 is 4763 volts minus reactance XS1 is 0.75 times, so 6.75 at 90 degree, and current IS is 349.9 rated current, but power factor is 0.8 and leading 0.8 power leading power factor. So cos inverse of 0.8. So computing the EMF E1 comes as 6462.3 at minus 70 degree. At rated field current and 750 rpm, induced EMF E2, we have to calculate. Induced EMF is proportional to flux, that means field current and speed. So field current is the rated field current and speed is only 750 rpm. So induced EMF is 750 divided by 1000 times the speed at the EMF at the rated field current and speed. So it is 750 by 1000 and EMF is at rated condition is 8227. Induced EMF E2 at 750 rpm is 6170.25 volt. So what is the field current required in this part? Field current IF1 is E1, which we have calculated above, E1 divided by E2 into E2 corresponds to rated field current and 750 rpm, and rated field current is 50 ampere. So IF1 equal to E1 by E2 into 50. So E1 is calculated as 6462.3 and E2 is calculated as 6170.25, and rated field current is 50. So, this comes as 52.37 ampere field current required. So, power input P1 is 3, voltage is phase voltage is V1, current is rated current IS into cosine phi. So, 3 V1 here is 4763 into rated field current is 349.9 and power factor here is 0.8. So, this comes as 3999.6 kilowatt. Motor speed in radian per second is, speed in RPM is 750 into 2 pi by 60. So, this is 78.54 radian per second. Hence, the torque at this is TE is power by speed. Power is computed as 3999.6 kilowatt and speed is 78.54 radian per second. So, torque comes as 50,924.4 Newton meter. Second bit corresponds to motoring at 1500 RPM. So, for 1500 RPM, what should be the frequency, supply frequency? F is 1500 divided by 1000 into 50. So, the 1.5 times rated frequency 50. So, it is 75 hertz. So, because frequency is 1.5 times, reactance, synchronous reactance XS2 is 75 divided by 50 times the reactance at rated condition, which is 9 ohm. So, it is 13.5 ohm. Applied voltage, phase voltage, because frequency is above the rated frequency. So, voltage is equal to rated voltage. So, applied phase voltage is V, that is 6350.85 volt. So, induced EMF E at rated field current and 1500 RPM, because induced EMF is proportional to speed and field current. So, we will denote this EMF as E3. E3 is, speed is 1500 times. So, 1500 by 1000 into EMF at rated speed 1000 RPM and rated field current. So, this comes as 1.5 times EMF E at rated condition is 8227 volts. So, this EMF E3 comes as 1.5 times of that is 12,340.5 volt E3. Torque, let us denote it as T3, that is half of rated torque. At this condition, torque is half of the rated torque. Speed is 1500 RPM, that is 1.5 times rated speed. So power Pm dash, which is proportional to Pm dash is always product of torque and speed. So Pm dash is half of rated torque, torque is half of the rated torque, and speed is 1.5 times rated speed. So it is 0.75 times rated power. Rated power is 6 megawatt. So 0.75 times 6. So it is 4.5 megawatt. So Pm dash by power angle characteristics, Pm dash is given by 3. Voltage is, applied voltage is V, rated voltage. Induced EMF is E3 divided by XS, at this condition XS2 into sin delta. So Pm dash is calculated as 4.5 megawatt, and that is equal to 3. Voltage is the rated voltage 6350.85. Induced EMF at rated field current and 1500 rpm is calculated as 12,340.5 volt, and reactance at 1500 rpm is 13.5 ohm, because frequency is 1.5 times the rated frequency into sin delta. So from this, sin delta is calculated as 0.258, and corresponding to this delta, load angle delta is 14.98 degree, and it is motoring operation. So motoring operation means induced EMF will be behind the applied voltage. So if this is V, E is here, and this is the angle delta, which is positive. This delta is positive, and V is lagging. V is lagging. So we can calculate the stator current Is using the phasor equation. Applied voltage V minus induced EMF E3 divided by JXS2. Applied voltage is, phasor is 6350.85, its angle is 0, minus induced EMF E3 magnitude is calculated as 12,340.5 volt at corresponding to 1500 rpm and rated field current, and delta angle for E3 is 14.93, 14.98 behind the voltage V, because EMF is lagging behind the voltage. So this is minus 14.98. V is the reference phasor, divided by reactance at 1500 rpm is 13.5 ohm. From this expression, stator current is computed as 475.5 at an angle 60.2 degree. So stator current Is magnitude is 475.5 ampere, and power factor is cosine of 60.2. So it is nearly equal to 0.5 leading power factor, because current is leading the voltage, the angle is positive. Then third bit corresponds to generating operation at regenerative braking operation at 750 rpm. So third bit also relates to similar condition to bit 1 where the motoring is at 750 rpm. So calculations can be taken from bit 1. So at 750 rpm, frequency F is 37.5 hertz as you have calculated in bit 1, and reactance X S is stator reactance, because frequency is less, reactance is 6.75 ohm proportional to frequency, and voltage V is given as V1 because of V wave control, constant V wave ratio. V1 is 4763 volt, and induced EMF E1 corresponding to this condition is 6170.25 volt. As calculated in bit 1, we have induced EMF is at 750 rpm and rated field current is 750 rpm is 6170.25 volt. So we will calculate power using the power angle characteristics. Power is PM is 3 times voltage V is V1, induced EMF is E1 by JX1, this is XS1 into sin delta. In this condition, speed is given as, power is given by 4.2 megawatt and generator. So minus 4.2 into 10 to the power 6. As sign convention, motor power is positive when, and for generating operation power will be negative. So PM is 3, voltage is V1 is 4763 into E1 is 6170.25 divided by 6.75 into sin delta. So with that, sin delta comes as minus 0.32 and delta is minus 18.76 degree. So stator current IES phasor is induced EMF E minus V by JXS. Since for generating operation, induced EMF E equals to terminal voltage V plus JXS IS. So induced EMF magnitude is E1, that is 6170.25 . So stator current IS is calculated as 334.66 ampere and its power factor is 0.878 lagging. Fourth part corresponds to 1500 rpm and generating operation. At 1500 rpm, synchronous reactance XS is 13.5 ohm because frequency is 1.5 times. Voltage V is the rated voltage, that is 6350.85 volt. induced EMF at rated IF and 1500 RPM is 1.5 times the 1.5 times the induced EMF at rated condition E, that is 12,340.85 volt. Rated current is IS, that is 349.9 ampere, is also the current in this part. So, what is the corresponding EMF? E4, let us write, is voltage V plus JXS into IS, reactance drop. V is rated voltage, so 6350.85, it is always the reference phasor, and reactance is 13.5 times 13.5, and current is 300, rated field current 349.9 at unity power factor. So, phase angle of the current is 0, same phase as the voltage. So, this EMF comes as 7915 volts and its phase angle is 36.64 degree. So, the field current required to give this EMF, field current required for generating operation at 1500 RPM to give rated power factor, rated field stator current at unity power factor is calculated like this, because EMF is proportional to field current and now EMF is decided, the required value of EMF is 7915 volt and at rated at 15 RPM and rated field current EMF is 12,340.85, that is the induced EMF at rated field current and 15 RPM, 1000 RPM, because rated field current is 50. So, this field current comes as 32.07 ampere. So, power PM 3 V E by XS sin delta, that is 3, supply voltage is 6350.85, that is the rated voltage. EMF at this condition is 7915 volt and reactance is 13.5 because frequency is 1.5 times and delta is 36.64 degree. So, sin delta is 36.64 degree. So, this power comes as 6.666353 megawatt and this is generating action. So, delta is negative, delta is positive and power is for generating it is power is negative. So, speed is 50 pi radian per second, hence the torque is, that is Pm by 50 pi power by speed is the torque. So, it comes as 4239 Newton meter. So, fourth bit corresponds to regenerative braking operation at rated armature current 1500 RPM and unity power factor. So, because it is regenerative braking, power magnitude is given by 6.666 megawatt, and it is negative. Torque is 42,439 Newton meter in the opposite direction, because it is the opposite direction to the rotation. So, torque can be mentioned as negative, and load angle delta is 36.64 degree. So, if we draw the phasor diagram for understanding, voltage V is reference, unity power factor stator current. So, IS is here, the stator reactance drop JXS IS is like this, and this is the induced EMF E, and this is the angle delta. So, delta magnitude is calculated because induced EMF rotates ahead of the supply voltage. You see, in a motor, the cause of rotation is the applied voltage to the stator, which produces the rotating field, and because of rotation induced EMF is generated. So, induced EMF is the effect and cause is the applied voltage. So, in a motor, V is ahead of the induced EMF. This is for generator. This one is for generator. For unity power factor motor operation, this is V, this is IS, this is JXSIS, and this is induced EMF E, and this is the delta load angle. So, for the motor, the relation between voltage phasor, induced EMF phasor, and stator reactance drop is, in a motor, applied voltage is V phasor, that is induced EMF phasor E1 plus JXS into IS phasor. So, which corresponds to this phasor diagram shown here. And for a generator, the voltage and induced EMF relation is also the same, that is V plus the stator reactance drop JXS IS is the induced EMF E, generated EMF E. So, this is the phasor relationship for generator, and this is the phasor relationship for the motor, and this is the phasor diagram for the motor, this is the phasor diagram for the generator. So, obviously, for generator and motor, the power angle delta will have opposite sign. So, power sign is accordingly power sign will also change. For a motor, power is positive. So, delta, this is the positive delta. Delta in this direction is positive. For motor, power is positive and delta is positive. But E is, this is the one part. For generator, by sign convention, power is negative. So, this is the negative delta. So, it corresponds to motor sign convention also, because it is in opposite direction, delta is negative. So, for generator, power is negative and delta is negative. So, load angle delta magnitude is shown here, and it is in opposite direction. And when you relate the V and E, we always take V as reference phasor and induced EMF phasor. For motor, E equals to the magnitude of the induced EMF, and because cause is the applied voltage which is the reference phasor, and effect is the induced EMF phasor. So, induced EMF in a motor, the voltage phasor is ahead and induced EMF phasor is behind, because induced EMF is the effect. So, angle is E minus magnitude of the delta, and for a generator, induced EMF is the first cause and the applied voltage is the second. So, induced EMF is magnitude of the induced EMF and its angle is plus magnitude of the delta. This is how we define the induced EMF phasor for the generator as given here. Magnitude is same, but phase angle is plus delta because voltage is behind, voltage which is the reference phasor, applied voltage which is the reference phasor is behind the induced EMF phasor, and so induced EMF angle is positive plus delta. And for a motor, this is the phasor relationship, magnitude is same because induced EMF is behind, rotating behind the voltage phasor E, its angle is minus magnitude of delta. So, for a motor, delta is positive. So, magnitude of delta is, as delta is positive, magnitude is same as the angle. So, it is, so induced EMF is E minus delta. And for a generator, delta is negative. So, it is minus delta. So, this remains the same. For a motor, by sign convention, power is positive and load angle delta is positive. So, magnitude of delta is same as delta. So, E phasor is given as E at minus delta. And for a generator, load angle delta is negative and power is negative. Because delta is negative, magnitude of delta equals to minus delta. So, phasor E is magnitude of E minus delta. So, E phasor remains the same for motor and generator. Thanks for attention.